In this lesson we're going to look at electromagnetic induction. Now, electromagnetic induction occurs whenever a conductor passes through a magnetic field. So in this case we've got a conducting loop, and when the conducting wire cuts through the magnetic field, a voltage is set up across the wire called an EMF, which drives a current around the circuit. So for example, moving the conductor in this direction through the magnetic field drives the current this way, which will cause the ammeter to displace to the positive side. So we can say that a voltage is generated across the conductor. This is also known as an EMF or electromotive force, and this electromotive force drives a current around the circuit. So the direction of the current that flows around the circuit depends on the direction in which the conductor moves through the magnetic field. So if we move the conductor to the right, away from the magnet, then the current will change direction, and the ammeter needle will flip to the left, to the negative side. So the third thing we need to mention is how we can affect the size of the EMF that's generated and the subsequent current that flows in the circuit. And so we can say that the size of the EMF and current flowing in the circuit increases as the speed of the conducting loop increases. So if I move this conducting loop quickly through the field or quickly towards the field, then the current will increase. And the second factor is the intensity of the magnetic field produced by the magnet. So if the magnetic field strength increases, then the size of the current will also increase. Now, a third way I can increase the size of the current is by introducing more loops. That's to say, if I change my single loop into a coil or into a solenoid. Okay, so as the solenoid cuts through the magnetic field produced by the magnet, a current will be induced in the coil. Now, it doesn't matter whether the magnet enters the coil or whether the coil moves around the magnet, a current will be induced in the same direction, in this case causing a positive flow of current so that the needle flips to the right. And if I change the direction, if I move the magnet out of the solenoid or the solenoid away from the magnet, then the current will flow in the opposite direction again. So what you really need to know now, you don't really need to worry about working out which way the current will flow, but what you do need to know for your GCSE, IGCSE, is that if you change the direction of the magnet, then the direction of the current will change. Now again, just applying these rules to the solenoid, we can say that the size of the current that's generated in this loop again depends on the speed of the magnet entering in and out of the solenoid, and B, on the strength of the magnetic field. So the faster the magnet moves, the greater the current. The stronger the magnetic field, the greater the current generated in the solenoid. And third important point is the number of loops in the solenoid. So by increasing the number of loops in the solenoid, we increase the EMF generated and the size of the current. So if I have a tightly wound solenoid with lots of loops, then I'll produce a larger EMF, larger current, whereas a loosely wound solenoid with fewer loops will produce a lower current. So the size of the EMF increases as the number of turns in the solenoid increases.